Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the LWJGL series. So in this episode, what we're going to be going over is a problem that everyone faces and I haven't really found many good solutions to. So we all know what the solutions should be, but I don't have any explanations I found that are good. So this problem is aspect ratio. Now in your game, if you are shipping to multiple different hardwares and multiple different devices, and especially if you're shipping to PC, you are going to have the problem of everyone having a different resolution on their monitor. And what do you do when everyone has a different resolution? Well, you have to either come up with a custom solution for each resolution, or you have to come up with a generic way to handle it, to figure out what their resolution is, and then automatically adjust your entire game so that it fits that resolution. Now there's a bunch of different approaches to this, and I will talk about a few of them, and some of them can give players an edge in, say, multiplayer online games, and some of them cannot. And so we'll talk about the different solutions that some of the people have gone through, and then we will talk about what we're going to do, and then we'll actually implement it. We're going to be only doing 2D too, so 3D, it's a different solution entirely than what we will be doing in 2D, and we will be working with orthographic projections. But let's see what this problem is and see how we can solve it. So before we begin to actually code, like always, I like to draw out a couple of concrete examples so we know exactly what we're dealing with. Now, let's say the user's window looks something like this, and the aspect ratio we are targeting is 16:9, which is an HD resolution. Let's say that's the resolution of their actual monitor size. Now, what are we going to do to our image when the window looks like this? There are a couple different approaches. The first approach, you can simply just crop your image. Let's just pretend, I know this doesn't look like it, that this is HD resolution, and then do some black bars. So then these will just become black bars. Now if you've ever played like old school Halo on a new computer, then you will see that it does this if you have it in the wrong resolution. This is super simple and it works. It just works. You don't lose any information on your game screen. Everything will appear exactly the same way it should. And in my opinion, this is probably the best solution, because if the user has their window like this, then they're trying to do something weird anyways, and they should typically always have it just full screen mode or in aspect ratio. Second solution, instead of doing this, you could make your window or your game actually sort of extend beyond the bounds of the screen like this, so that it is in HD resolution. And now what happens is you're just losing some portion of your game all out here. Now, this can work. I'm not going to automatically say that it can't work, because it can. Typically what games will do if they want to support something like this is they'll have some sort of like fluff on the edges and stuff. So it's like background parts of their image, you know, sort of part of the HUD and everything. And it's just sort of like not necessary to the gameplay. And then the users won't even notice if it's getting cut off a little bit. And that's a good approach. I feel like this is probably the best approach for things like mobile games though, because with mobile games you have a ton of different resolutions and you're gonna have the screen size be kind of messed up no matter what you do. That's probably a better idea in a mobile resolution game, but this is only one case. There is still one other case, which is, what if their screen now looks like this? It's a little bit taller than it is wide. So then in this case, once again, we could do bars up here and down here. This is now the black bars. And then the opposite solution to this would be, once again, just to extend the game view outside of the window. So now that we know what each of the cases are, I'm going to say we go with this black bar approach because it typically works the best. So let's do a actual example now so that we can sort of see how this stuff works. So what the approach we're going to take is we're going to initially set our target width. So we're going to say, okay, let's just initially set like this guy's width to be whatever this is. We'll call this SW for screen width. So we'll say TW for target width equals SW for screen width. Then what we can do is we can calculate what the target height would be. So we'll say the target height is now equal to the screen width over our aspect ratio. And we know it's over because this 16:9, right? 1920 by 1080, that's width over height. equals r, which is our aspect ratio. So if we want to know how big a height should be, well, we know that height, we would multiply it up here, and then we would divide r back down. So we would say r times height equals width, and then we would say height equals width over r, which is what we're doing right here. So this would give us a target height, but what's going to happen is it's actually going to be like way bigger than what our actual screen size is, because in order to maintain aspect ratio, we're going to have a pretty high height. So then what we can do is we can say, well, if we try this and then the target height is greater than what the screen's actual height is, then we will just match the height instead. So then we'll say, okay, well then we'll use this height and we'll use whatever width we can get. So then we'll say, okay, well then target height is equal to the screen height. And then we'll say target width is equal to, what would we do? Well, we want to multiply h up so that we get w by itself. So it would be aspect ratio times height if we go from here down to here. So then we would just say, okay, well then the target width would be the target height times that aspect ratio r. Then what this is going to do is we're going to try this initially, and the height's going to be way too big. We're going to see that. Then we're going to break into this loop, and we're going to say, okay, the target height is this guy, which could be any number. And then what's going to happen is it's just going to clip the width to maintain that aspect ratio. So this could be 1920 pixels, the width, or it could be anything less than 1920. So it's going to be less than or equal to. There's no way it can be greater than that, because if it was, then it would be greater than this height. So that solves the problem of figuring out what this target height and what this target width should be. But how do we figure out how to position it so that it's centered? So how do we, now that we know what our target width should be and our target height should be, now that we know those, how do we make sure that we center it so that the beginning of this point is going to give us an equal amount of black space on the left and the right? Well, that's pretty simple. We know what the length of this is, right? Because that's just the target width over 2. So we know that this x0 equals target width over 2. And we know what the length of this is. This is just the screen width over 2. So we'll say that's x1. So x1 is equal to the screen width over 2, which means if we subtract this from this, then that will end up giving us this remaining space right here. So we can say that remaining space, which is our padding, so we'll just say pad, equals x1 minus x2. And then we can do the same thing for the screen height. Now notice the screen height equals the target height in this case. So what we're going to end up getting is, well, these are equal. So if I do the pad for the y, that's going to be screen height over 2 minus target height over 2. Well, these two are equal. So that just means it's going to be 0, which means we're going to have it perfectly fit within the window. And then if you actually do the equation and do everything that we've worked out, it will work the same if we end up getting a screen size that looks like this, except it will give us padding vertically instead of horizontally. Okay, so I think that's enough explanation. Let's actually code this and try and get it working for ourselves. So the code is actually going to be more of a trivial part. Now, I'm going to use this little template that is literally from the 2D Engine series as it is at this moment in time. So at this moment in time, we just finished episode 14, which is sprites. So if you want to follow along to figure out how I got to this point, you can literally follow the 2D Engine series. But this is nice because it gives us a minimal engine, and what I plan to do is just sort of add on to this as we get more requests for how to do certain things. That way we can sort of just use this and plop it into your own project, and you can start developing immediately. So what I'm going to do so that you guys can follow along with this video is I have actually updated this. So you'll notice it now has 19 commits, and this is actually from the video that I just recorded. But what you guys will want to do if you want to follow along is follow along from here. So we can actually do that pretty simply. Just open up to wherever you would like to place this project, then hit new folder. I'm going to call this test aspect ratio. Then go into here and I'm going to hit Shift and right click, and I can open up a Linux shell. You could open up PowerShell, or Git Bash would probably be the best if you have that. You will need this in order to execute the commands I'm about to do. So if you don't have Git Bash, I would definitely recommend installing that. Then we can go into here, and I'm going to say git clone, and I'm going to go back into here, go to this link, and I will list these commands in the description so that you can just copy and paste them. But this will clone the repository. So now if I look up here, it says we have minimal LWJGL engine. I'm going to just put that up here, delete this. Then what I'm going to do is I'm going to check out the commit before this video. So I'm going to click on the commits, click onto this update window, and I'm going to copy and paste this commit ID. So we would copy that, and I can say git checkout and right click. Now it's going to tell us you're in a detached head state, all blah, blah, blah. That's perfectly fine. It's just basically telling us if we make any changes, it's not going to reflect, which is true because you guys aren't going to be pushing to my GitHub. So that's fine anyways. But basically now what we have is we have the code as it was in that commit. So now if we go into IntelliJ and we have file, new project from existing sources, then we can go into where we created this test aspect ratio. I'm going to hit OK. I'm going to say import it with Gradle, hit finish, open it in this window. I'm going to right click this build.gradle, and then I am going to go all the way down here, and we're going to say import Gradle project. And what this is going to do is it's going to open up this window, and if I open up the build view, then we can see that the build was successful. So now to get this fully working, I will just go into here, go into source, main Java, click onto this main class. I'm going to get that out of the way now. It says I need to set up JDK. So if you need to do that, then just click onto this and select whichever version of Java you have on your machine. Now I should be good to go. I will hit run, hit main, and you should get something that looks like this. So actually you should get something that looks exactly like this. This is just going to be the Mario project. So now that we have this up and running, let's look a little bit at what we got here. So as you saw, we have some sprites. I basically have a minimal entity component system and everything, or not entity component system, but a component pattern with some objects and stuff. And we have this base scene class, which if we go into, we can see just loads up a camera, a sprite sheet, and then a couple of sprites, which were our Marios. I added one thing that's not in the 2D engine series, which is this window resize listener. So every time the window is resized, it calls GL viewport, which basically tells GL, hey, this is the new viewport we'll be using. And I set the window's width and height. So now if we run this again and I resize this, if I drag it to the right, Mario gets squashed. And it just does that. And that's because of this call to GL viewport. Because what you're saying is, hey, GL, this is the viewport I want you to draw into. And so that's drawing into whatever the width and the height is, and it's just scaling everything, which means it's going to squash if it's not in the aspect ratio you want. So we're going to fix that by doing exactly what we talked about just a moment ago. So I'm going to take out this call to GL viewport because we are going to have to change that. And then what I'm going to do is say, let's figure out the largest area that fits this target aspect ratio. So we are going to say we want to figure out what the aspect ratio is first of all. So let's actually go into our window class. And inside of here, I'm going to add in a couple more. So we have the width and the height of the window. Then I'm going to say we actually have the virtual width. Actually, let's call these target width. The target width, which I'm going to say is 1920 for now. And then private int target height, which I'm going to say is 1080 for now. We will change this so that's the actual user's monitor width and height. And then we'll say private float target aspect ratio is equal to float the target width over float the target height. So what we did is we just said, hey, this is the width and the height we are targeting. We want it to be HD. The aspect ratio is whatever this is. So now let's actually provide a way to get that stuff too. We'll just say down here, public float get target aspect ratio. And then inside of here, we will just return this .target aspect ratio. Going back into our window resize listener, now we can actually figure this stuff out. We'll say like we said, that the aspect width, so this is the width that we're going to try and set it to, is just going to be screen width. I'm going to rename these. This is what the new screen width is. This is the new screen height. And then I'm just going to copy that here, copy that here. We're going to say that the aspect width is equal to the screen width. So we're initially going to just try and set it to the width. Then we'll say the aspect height is going to be equal to, cast it to an int, and we're going to say the aspect width over window.get target aspect ratio. Remember we said we have to divide by the target or by the ratio in order to get the height. So that's what we're doing. And then what we're going to do is we're going to make that check. We're going to say if aspect height is greater than the screen's actual height, we've just resized it and it's too big for the actual window. So what do? We just clip the height. We say, okay, it doesn't fit our height, so we must switch to pillar box, which is what those black boxes are called. So we'll say aspect height equals the screen height, so we'll set it to the screen height. Then we'll say aspect width is equal to, once again, int, cast it to a float, the aspect height times the window.get aspect or target aspect ratio. So remember we said if we go into this if statement, we literally just multiply instead. Now we want to figure out where we need to center it, right? We want to figure out where the bottom left corner of this rectangle should be. So we'll say center rectangle. Then we'll say the viewport X, which is basically what this is going to be. Where is the bottom left? This is the viewport X. Is going to be int float. Actually, let's do another parenthesis. So float inside of here. Screen width, we're going to cast our screen width over 2f minus, there we go, float aspect width over 2f. So remember what I said, we can find that, we can basically just find that left corner by subtracting the aspect width. So this is the width that our screen is actually going to be from what the screen width actually is, and that will center it. And then we'll do the same thing for the viewport Y. We'll just say float screen height over 2f minus float screen aspect height over 2f. And that will give us the appropriate centered Y. Then we can just say GL viewport. We're going to give it VPX, VPY as the bottom left corner, and aspect width and aspect height as the width and the height respectively, which will change our viewport. So now if we run this again, if we go like this, notice they main in aspect, but we can't really tell what's happening, right? It just looks like they're moving around, which is kind of weird. So let's give it a background so we can actually see what's going on. We'll go into our base scene one more time, and let's add one more game object. Actually, I'm going to do this before them so that it is behind them. I'm going to say background equals a new game object. This is going to be background, and we're going to say this is a new transform, new vector 2f. So this is the position. I'm just going to set that to 0. New vector 2f. This is the width and the height. I'm just going to say 1920 by 1080 since that is the resolution of my monitor. You would set it to whatever the resolution of your monitor is, which will make this look good. Then we're just going to say background to add component, new sprite render, and I just want to render a color here. So I'm going to pass in a vector 4f. So we'll say new vector 4f, and this is going to be 0.53f, 0.91f, 0.91f, which will give us like a blue, and then 1. So we're just going to draw a color, and then we will add this to our game objects. We'll say this.add game object to scene background, which should add this in. So if we run this one more time, I'm going to reset the camera's transform to 0, 0 so that we're actually centered on the screen. We get a blue background with the Marios. Now if I minimize this and I stretch it, we get the black bars, which is exactly what we wanted. And I can actually move the camera around, which makes it look weird because the background is not like moving with the camera. So that's not right. But then if I resize it vertically, you'll notice those black bars get bigger and it maintains that aspect ratio. And if we go too big, then we get the vertical bars. Now, how can we do this last step, which is to make this actually maintain the aspect ratio of the user screen? Well, we can do that pretty simply. If we just go into the window right here, right before we actually create change scenes. We actually go into the scene. We're going to grab the user's monitor and see what the screen width and the screen height of that monitor is. So we can say GLFW vid mode. Vid mode, this is basically just like what, it's like a class that GLFW uses to basically tell you what monitor it is. We'll say GLFW get vid mode, video mode, and GLFW get primary monitor is the monitor we want. So we'll just get their primary monitor. If they have multiple monitors, it'll just pick whichever one they set as primary. Then we'll say this dot virtual width, target width, sorry, equals vid mode dot width. This dot target height equals vid mode dot height. And then we'll say this dot target aspect ratio once again is float this dot virtual or target width over float this dot target height. And that should give us the new thing. I'm going to print it out real quick so we can just make sure this works right. So if I say this dot target width and copy that and just do the target height, we will see that it is my actual primary monitor's resolution, which is 3840 by 2160. And then that is the aspect ratio it will try to maintain. What you could do is if your game has a settings menu, you could have them select from a variety of different resolutions, and then they can just, or actual screen sizes, and then you can just set the target width and target height to those, and it will all work the same once again. But yeah, this is just one way to solve this problem, maintaining aspect ratio. There are several other ways that you could do this. I thought this was the simplest and the most ideal for what we want to do, because your elements will remain the same relative to your screen size. Notice they never changed position relative to this left corner, which is exactly what you would want in the case of like HUD items and stuff like that. So yeah, I hope you guys enjoyed this. If you did, please hit like and subscribe. And if you have any suggestions for things you would want to see a video about, leave a comment and I will consider doing it in a tutorial. And we can make this little minimal GL project even better. So I'll see you guys in the next tutorial. Thanks.